Next slide. Our Casino facility is the facility that we do the manufacturing for the V-Series product line. It's a 120,000 square foot facility. Independent power feeds, has class 10,000 and 100,000 clean rooms. It is a secure facility, so we can do secret work and classified work, redundant IT infrastructure, and we are ISO 9001 certified. So the V-Series is a bypass capacitor. For overview of a bypass capacitor, essentially capacitors are used to prevent the noise from entering a system, bypassing it to ground. And there's just a high level of what a bypass capacitor does. Really, the major factor is the aspect of capacitor RF performance is driven by the parasitic inductance, which causes the positive slope after resonance. You can see over to the right, there's a chart showing that very situation, and it is the reason why we have to offer multiple different values for the V-Series, because not one value is going to fit for all. It depends on the application and what frequencies the power of the amplifier is going to be using and operating under. The reactance of the capacitor added to the circuit should be 1 to 10th or less resistance in parallel. This is the formulation below. It's 1 over 2 pi of C. That's the formulation to understand what capacitor or bypass cap is best suited for your application. You can see where the different capacitors, the highest level capacitor that Knowles previously offered was 0.01 nanofarads, and we are now offering the 0.1, the 100 nanofarad. 100 nanofarad. The 10 nanofarad is, 10 nanofarad is what we offered previously. Highest, now we are at 100 nanofarad. You can see it performs better at the lower frequencies. The impedance is improved, and I'll show you that in our performance as well later on in the slides. Product types. So this is the V-Series overall. So the V-Series overall is a high-frequency wire-bondable single-layer capacitor for GaN and gas amplifier applications. Small size improves the impedance and is a key to the performing within the circuit. Small size means smaller bonds, smaller leads. Has X7R temperature stability, which is industry standard and actually very, very stable. Excellent frequency response. Again, it's wire bondable, which is requirement for the application. We are RoHS compliant, and the functional applications for these are DC blocking, but primarily it's used for bypassing, filtering and tuning, coupling, not so much, but for the RF bypassing is the primary application for these parts. This was the original featured offering for the V-Series. You could see there's the 1 nanofarad, 2.2 nanofarad, 4.7, 6.8, and the 10 nanofarad was the largest we went up previously. We have now extended that, and I will show that on the next slide. One of the advantages we have over our competitors is the voltage rating. We offer a higher voltage rating than our competitors at the same size, and that's one of our key advantages of our competitors. Okay. The 100 nanofarad bypass capacitor. This is the newest release for that. It has the highest capacitance and the smallest footprint for the highest voltage rating, and it's a 0408K size, 100 nanofarad. You can see that we offer this at the 25 volt and a 50 volt rating. Either one, we've qualified it for both. It has a nickel gold termination, and the size and the tolerance is 20%. This is the attachment method is compatible to epoxy and solder solder attachment. Bonding can be done either with a needle or automatic dispensers. We've had no issues really with the epoxy attachment. I believe that's probably the typical standard method of attachment for these. The solder attachment is no issue either because we do have the nickel on there. I'll get into the RF performance. So the benefits of using the V-series in an amplifier, again, what I said, the major aspect was the parasitic inductance, which causes positive slope after resonance. You can see here with the V80, you see the suppression of 35 dB, negative 35 dB. It is performs better in the lower frequency bands across the broader scope than our V30. So the performance is improved, which you would expect from a higher capacitance part. This is about a 98.2% efficiency, and this is also the reason why we are able to do this is because we reduced the parasitic inductance by increasing the contact pad size without compromising the voltage rating. So we were able to provide this performance without compromising voltage rating, which is a key factor for us. Oh, questions. Does anybody have any questions so far?
You can use the chat. You can use the chat room, or you can unmute yourself.
So far.
Yeah. Okay. So the benefits and applications, again, excellent high frequency response. We are operating temperature 55 C to plus 125 C. This part is wire bondable. A reduced footprint by using a single bypass capacitor or reducing the number of capacitors required. It was found that carrier tone suppression levels were comparatively similar to capacitors at frequencies lower than 100 megahertz. And the recommended for usage in the circuits that require RF bypassing, filtering, and tuning coupling. Common applications include power supply filters, reduce and ripple currents and voltages. Now we do have test capabilities for this part. We can upscreen to group A and group B if you need it for a flight or space application or any type of high rail application. We've done extensive life testing, 2,000-hour life testing on these parts, and also element and group A as well. So that capability is available. We have had customers request that. We also are offering the 38534 mil-perf Rev L version as well now. That was just updated in December 2020. That includes a lot more different additional testing, which is 100% CSAM. We have that capability internally, so that's another offering that we can supply. The testing capabilities in detail are what we are offering, and a little bit more about the environmental testing, physical testing, mechanical testing, and electrical testing. Cherian, Cherian is our application engineer. Cherian, would you like to go a little bit more detail about the 100 nanoflare bypass capacitor?
I think, yeah, so basically, just like Ian said, the 100 nanofarad gives you the highest capacitance, and The reliability also, we have tested it to 2000-hour live test, and has a flatter surface area. So the process that involves the manufacturing of that part also is very good flat. So basically, use it on compared to any other product in the market. Yeah, other than that.
Yep. Yeah, that's a key distinction. So the flatter surface area was one of the key things we reviewed and made sure was addressed on the V80 construction. So we are now using a different, I would say, different termination process than the V30s for the V80, which will allow the process to be the part itself to be flatter.
Ian, I have two questions. First, do we have models available such as monolithics?
Do we have monolithics of this is a this is a
No,
single
we
piece of
don't.
construction. Yeah.
Yeah, I don't. No, we don't have the models available.
You're talking about for DC blocking?
Yeah, it's
Yeah,
for DC
Jason.
blocking, yeah.
For DC blocking? No, yeah. So the monolithic for DC blocking, we are actually still in works of designing. This is that's still in the infant stage, but we are working
Okay.
on it.
All right.
The second question is, how easy to get samples?
We have samples on hand. We can get samples out to you guys this week if you want. We can also supply the live testing data too for review.
All right, thank you.
Yep. Yeah, so I mean, unfortunately, I wish I had more to go over, but this is really the gist of a bypass cap. It's to suppress the noise, and really we've been offering this now for some time through different values. However, we did have a gap in our catalog for 100 nanofarad, and primarily one of the more common bypass capacitor values for the industry. It was a major gap in our catalog, and we believe that this is going to be potentially a major seller for us, and could be competitive because we offer a higher voltage rating at the same case size as our competitor.
All right, thanks, Ian. So we'll open it to the floor for questions. Again, you can use the chat feature or unmute yourself. Question is, what's typical lead time?
Typical lead time is about 6 weeks. Since these are standard parts, we always are making these parts. We have these on stock, but if we didn't have them in stock, we would be 6 weeks. If we have them in stock, we can ship in 1 to 2 weeks or less.
How do we get a data sheet for this? Is it on the website?
Yep, it is on the website,
Okay.
but we can send it to you as well.
Any other questions?
The main takeaway here is definitely that the V80 will have a better suppression at the lower frequency range than the V30. You can see here that this dip right here shows that it goes down to a minus 35 dB all the way as early as 10 gigahertz, where the V30 didn't see that until later on in the frequency band.
Scott, can you send us this presentation? You have a PowerPoint?
Yes, we'll do, Don.
Yes, it'll be available for everyone. We'll make sure everybody gets a copy.
Just a comment. I don't think the world really has gotten the word yet that Dielectric Labs has been bought by Knowles, I think. I don't think they generally are aware of it, so I think we might have had a better turnout if
Oh,
some
if
of the,
DLI was mentioned in this?
yes.
Okay, no, that's a fair assessment.
Yeah, thank you.
Okay. The way that we've kind of marketed this is Knowles is the company and DLI is like the brand. So anything that ships out of here always has a DLI branded label. But Knowles is the overarching company. So yeah, I'll make sure to reference that moving forward.
Do you have any plans to create a new product with the dual capacitance like your competitors do?
You're talking about the integrated
Yes.
packaging? Yes. So we are working on that as well. So this is a good I didn't want to bring so you see in here this what you're talking about is adding the 100 picofarad single layer and including it with your 10 nanofarad bypass capacitor to reduce even more the footprint and the bonds that you have to do by
Yeah, all on one chip. Yeah.
all on one chip. Yeah, so we are looking at that. However, we have to go about it obviously a different way. We're not going to infringe on our competitors' design. So we are working internally to do that our own way for sure.